the topic has been addressed by this team: Eleanor Montuski, Ann Thresher, Matt Soliman, Jeremy Hardy, and me, and Matt are UCSD postgrads. And we have been writing this book. It's now finished. Tangle of Science, Reliability Beyond the Scientific Method, Rigor and Objectivity. And the conceptual engineering I'm going to talk about today is done in this book. So I'm really reporting on a bit of conceptual engineering we did in the book, though we didn't call it that. The work we're going to talk about is, I think, in the intersection of your project on conceptual engineering and our project in pushing forward the philosophy of social technology. And what we were concerned with was the idea of the objectivity in the use of scientific products, because the book is really about the reliability of scientific products. And we were concerned, among other things, with the objectivity of objectivity in using them. Now, so what we were concerned with was assessments that our claim is that many people want to insist that assessments that this scientific product is reliable. Let me just move you folks out of the way. I've forgotten how I do that. Yes, there it is. That this scientific product is reliable for use should be objective. I mean, that's a kind of standard assumption. But objectivity, though, is usually thought to be too complex, too open-ended, too ambiguous a concept to do the work that we'd like it to do. So this has been argued by Ian Hacking. That's Ian Hacking on the right in the photo with his son Daniel on the left. Ian Hacking argues it is usually thought that the affirmative use of a term is basic, that to understand X, we need to know what it is to be X, and that knowing this apprises us of what it is to not to be an X. But for objectivity, it is the negative use that wears the trousers. That is, a definite sense attaches to the assertion that something is objective only in the light of a specific way in which it might not have been objective. This is following the work of the philosopher J.L. Austin, and also it's what both Lorraine Daston and Peter Gallison say about objectivity in their book, The History of Objectivity. I think they actually note it because I think I pointed out to them, it seemed to me that they were arguing that objectivity was, in Austin's sense, a trouser word. So Hacking's lesson he wants to draw from this is dump objectivity, right? Just get rid of it and replace it by a new concept. Just get on with the business of saying what you mean. Now, there are two strategies for getting on with the business of saying what you mean, neither of which really dump objectivity, but rather conceptually engineer it. So this first strategy is what we call the list strategy. So this is just a rough sorting of the many views about what objectivity consists in and how to precify that we find in the literature. But roughly, there are two kinds of lists. One that tells you the kinds of factors that comprise objectivity. Objectivity entails some or all of, we know all this, grasping the real, detachment, value, freedom, intersubjectivity. Or then another complex, faithfulness to facts, absence of normative commitments, freedom from bias, or unique interpretations of a body of data, shared method, et cetera, et cetera. The other thing that sometimes the lists do alternatively is they talk about methods or characteristics or ways to achieve these desirable goals like rigor, precision, accuracy, reliability, replicability, robustness, et cetera, et cetera. Okay. We call this kitchen sink objectivity when you've done it this way. After the World War II slogan, throw everything but the kitchen sink at the enemy. Okay, so this is one way of conceptually engineering, just long lists of, and then, you can treat the lists disjunctively or conjunctively, or leave it to context to pick out specific things. But the point is that if you're precifying it as they're trying to, you have to assume that there's some mechanism whereby context does pick up that specific characteristics if you just leave a disjunctive list. Okay. The second we think of is what we call, that precisification strategy. I mean, the first is a way of precisifying it, but it leaves it kitchen sinkish. This one is, zeroing in on something. Choose one, and there are two versions of this. Choose one unambiguous definition for universal use. That's what objectivity means. When you say objectivity, this is what you mean, anywhere, everywhere. The other is to vary the choice to suit context, but insist on a single unambiguous definition, for each use in each context. And that's what we call objectivity precisified. So there are two different kinds of conceptual engineering going on, resulting in two different kinds of objectivity. Now, you'll notice that what I'm doing here is talking in the first instance, giving what I'm doing falls into the first half of the conceptual engineering project, which is a case study. But also, I think this is moving into thinking more, what kind of representational devices are there? So for objectivity, there are a variety of different representational devices, different methods of dealing, of conceptually engineering the ambiguous and open-ended concept of objectivity. Now, those are two strategies that we've seen following Hacking's advice, to either dump it or get on and say exactly what you mean. But our team suggests that very, very often that's not what you want to do. You want to hang on to your ambiguity. Okay, and I'm going to explain the reasons for this. And this simply follows old remarks by Peter Hempel. There he is on the right with Dick Jeffrey on the left, who talks about the price of precision. An explication sentence, which is what you get, telling you how to engineer the concept. An explication sentence does not simply exhibit the commonly accepted meaning of the concept under study, but rather proposes a specified new and precise meaning for it. It's just, every time you do this precisification, either by a list strategy or what we call precisification, kitchen sink or precisification strategy, every time you do that, there's a loss. You lose the power in other contexts where the chosen precisification doesn't cut it. Okay, that's really what you lose is what I call, following Otto Neurath, the Bollung character of objectivity. Objectivity is a Bollung concept. Bollung is for instance, the German idea of a congestion where a lot of stuff is stuffed in, and it's not stuffed in any particular order, and the boundaries are fuzzy, so Bollung's Gebiet is one of the uses of the term in German, like a megalopolis where there's a lot of crowded into the city and with boundaries about where it ends, and then eventually that there's stuff that's clearly in it and clearly out of it. Okay, and Neurath argued that most of the terms that we use are really Bollung concepts. Now, one of the reasons that we're concerned with the fact that objectivity is a Bollung concept is we claim the duty to be objective carries a burden of responsibility. And I think that you lose, among other things, you lose a sense of the burden of responsibility if you do the either the kitchen sink or the precisification strategy. So we think that objective science is an essential ingredient in responsible science. And because it's a part of responsible science, it carries with it a responsibility. Or, I mean, maybe that's just not, maybe it's not a because, but that's just sort of a claim, right? So we we want to claim that the use of a scientific product is not objective unless the tool, sorry, I've changed from product to tool, okay. The use of a scientific product as a tool is not objective, because we think scientific products are always used for something. A measure is used for something, a model is used for something, a theory is used for something, an experiment is used for something, a laser is used for something. So we're always thinking in terms of scientific products and their use. And so we think that a scientific product or tool is not objective unless that product is the right tool for the right purposes, where right intertwines both epistemic and moral. And that one of the things we don't want to lose in conceptually engineering objectivity is this characteristic of objectivity, that I think that I would not be willing to call something, I think you've lost an important sense of the ordinary meaning and implications of the term objective if you call a scientific product objective when we're going to use it for a certain purpose, when it's not the right tool to use for that, or actually it's not the right purpose to be being served. Okay. So we think of objectivity when we're thinking of it as a Bowen concept, and why we want to keep it as a Bowen concept and what we want to bring out about it. We think of it as analogous to the concept of duty of care. So this is an odd kind of conceptual engineering we're doing right now. I mean, we're not engineering in the sense of providing an explication or a precisification or a list. Right? We're engineering in trying to, I think, make the concept more transparent, make transparent some of the work it does, and some of the work it often does that we would often like to continue to allow it to do, and what the implications of that are. So we think of objectivity as analogous to duty of care. So just think about English tort law. There must be and is some general conception of relations giving rise to a duty of care, of which the particular cases found in the books are but instances. So duty of care is this a Bowen concept. The rule that you are to love your neighbor becomes in law, you must not injure your neighbor. You must take reasonable care to avoid acts or omissions which you can reasonably foresee would be likely to injure your neighbor. That's what a duty of care is. It doesn't, there's no list. It's not the list strategy here, right? In either form, or the precisification strategy. And one of the reasons there's not the precisification strategy often is because as soon as you precify it in a particular way rather than another particular way, it's always possible to game the system, either intentionally or unintentionally. You know, you do the letter of the law and it just isn't at all what was intended. So the great drive to leave things like duty of care at an abstract level and treat it like this. For instance, the neighbor test is, well, persons who are so closely and directly affected by my act that I ought reasonably to have them in contemplation as being so affected when I'm directing my mind to the acts, etc. Okay. Now, the reasonable person, the person concerned, is sometimes described as the man in the street or the man in the Clapham omnibus. Such a man taking a ticket to see a cricket match at Lord's would know quite well that he was not going to be encased in a steel frame to protect him from the 1 in a million chance of a cricket ball dropping on his head. Okay. We think that objectivity often, not always, but often there's a real need to leave objectivity as a Bowen concept that's analogous to duty of care, and for much the same reason. Now, we said that objectivity is, we're thinking about the objective use of a scientific product, objective use for a purpose. We call on Ha-Seok Chang, some of his work on purposes to help out here. Ha-Seok distinguishes, he talks about epistemic activities or scientific practices, and scientific practices achieving some goals. And he distinguishes inherent or internal purposes from external. And we think this is a useful distinction to have when you're thinking about objectivity. His example is, one of his examples is match lighting. And the inherent purpose is getting a match lit. But the external purpose could be lighting a candle because the electricity went off, setting a forest on fire as an act of arson, wanting, or as Hasek says, to watch and admire the marvelous process that combustion is. So there's both the internal and immediate purpose, and then what that purpose is embedded in the context. And the context of use, when we're talking about, is this an objective use of this scientific product? The context fixes the inherent and external purposes. We've got a little bit to say in the book about context and what it might be that it could do that, but it includes all these things here. I don't know how to get rid of you folks, so I can't actually read them, but it includes the local norms and practices and it includes local conditions, or the conditions of the, the context of the actual situation of use. The context that helps fix the purposes includes both the physical and social facts, as well as the norms and practices and customs, and also the knowledge available. Oh goodness, I'm sorry. I did turn that off before. It just doesn't seem to have worked. Many apologies. Okay. Now, this all results, thinking of objectivity this way, results in what Eleonora Montesquieu, one of the authors of the book, has called objectivity to be found. And it turns objectivity into a demanding duty, like the duty of care. It's your responsibility to find the tools that serve the purposes with no unacceptable side effects. We haven't actually said that, but that is part of it. You're supposed to find tools that serve the purposes, but in serving the purposes, we don't want you to serve a whole lot of other purposes that we really don't want to see at all. And finding the tools that serve the purposes with no unacceptable side effects will then involve you in finding the range of the effects of using those tools, and then figuring out what is and what is not acceptable. And then in addition to that, you have to find the right purposes, both the inherent and the external ones. So the duty to be objective is a heavy duty, just as the duty of care is. I mean, for instance, there just are some people who ought not to take the job of selling insurance or of investment counseling for a bank, because they aren't good at understanding what their duty of care consists in this case with this client. And others are fairly good at sussing out what's implied by the customs and ranges and the actual deficits and advantages of this client. Okay. So let me give you an example that Leonora has developed with Pierluigi Barotta of a case where we think objectivity, the engineers involved failed to be objective in their use of certain bits of science. And this is the case of the Vajont Dam, okay, which is there in the Dolomites. There was a huge disaster. In the 9th of October, 1963, 10:39 p.m., 260 million cubic meters of landslide fell from Monte Toc into the artificial lake. I hope there's some Italians in the audience who, during the Q&A, will pronounce Monte Toc correctly for me. I did rehearse a bit, but I keep failing. Well, let me just tell you what happened. So all of this fell into the artificial lake behind the dam, and it created a tsunami, and the tsunami swept over the dam, and it absolutely destroyed many, many villages and killed many people and their livelihoods and animals downstream. For instance, here's Longarone right after the disaster. So I mean, this was a real tragedy. and they're in the Dolomites. Okay. Now, once this irresponsible science used, now I haven't said what that was used, but what was the way the dam was built, right? Irresponsible. We're going to look at one particular small piece of the decisions about how about building the dam, which is the illustration. Was it irresponsible? It has been decided that nothing criminal was done. Okay, so but still, there's a question of responsibility and okay. We also want to note that if we do find it irresponsible, right, that doesn't mean that this kind of case is unusual. We think that it's very likely that any other engineers or many other engineers faced in the same situation would have done exactly the same thing. I mean, this is just to back up the idea that it's really hard to take on this responsibility to be objective. But we do think that although it's not criminal and not unusual, it is a failure of objectivity. And that's because the wrong purposes were in focus, and hence, or concomitantly, some of the wrong tools were used. Actually, what we want to claim is that some of the right tools were omitted, okay, or a tool was used in too shoddy a way. So I want to think about assessing the purposes here. First, the inherent purpose. Most effort in designing this and building this dam focused on the formidable engineering challenges of just building a dam that would stand, okay? For instance, it's just one thing. A system of 146 equations with as many unknown variables was perfected and solved in order to build the dam. And a lot of engineering brilliance went into this. And the purpose here was they were trying to build a dam that would stand in that setting. Okay. But what about the external purposes? Well, I don't understand why I can't get it to shut off. I'm so sorry, folks. I mean, I really criticize my students if that happened, but it's something funny about the phone doesn't, anyway, never mind, sorry. The immediate purpose, external purpose that was explicit was the dam was being built to generate electricity, okay? And that was a clear objective, a clear purpose. Obviously, anyone would say it's an external purpose or qualifying, the purpose that it's to generate electricity safely. That's somehow so obvious that sometimes it doesn't get said and might not have had enough attention. Okay, there might have been other external purposes. But what we think happened was that the safety purposes were not taken seriously enough in the choice of tools, given the stakes. So in this case, we see here the intertwining of the moral and the epistemic in the concept of objectivity. So here was a bit of well-established scientific theory that was used. The lead engineer, Carl Semenza, sorry, I'll get Mihaela to pronounce him too. From a geological point of view, the rocks of the Veneto region are generally very good. Overall, the limestone is honest. It reveals its flaws on the surface. So they looked at the limestone and didn't see any flaws. We think that, well, it's pretty easy to say post hoc, but more is needed, more information and a more objective assessment, that more is needed. So what knowledge was overlooked? Well, local knowledge. And that consisted of two kinds, knowledge of local facts and knowledge possessed by locals. The knowledge of local facts, well, what knowledge was required? Or what knowledge might one have done? The chemical and physical characteristics of the rocks forming the terrestrial crust, they didn't show any flaws on their surface, but you could have done an analysis. Okay. The geological characteristics of landslides and their behavior, technological knowledge concerning the resistance of dams to the pressure of the water. We know that it's the problem, one of the problems was it withstood the pressure of water. It didn't leak or anything. Okay. So what we think was going on here is that there was too quick a move from the general or the generic to the particular, given the purposes. So and particularly the external purpose of safety. The generic is limestone wears its flaws on its face. Now, this is not an absolutely well-established universal generalization. It's not universally true. It's a generic. It tends to be, limestone tends to wear its flaws on its surface. So in this case, moving from a generic to a particular is not a question of logical implication. It's a question of building a judgment of whether it is good enough tool for the purposes in the context. I mean, it generally, you can assume it wears its flaws on its face. So if I want to assume that in this case, no flaws because there's nothing on the surface, is that a good enough inference for this case? And you need to do that with due regard to the moral demands. Okay, that knowledge, that kind of local knowledge of local facts wasn't sufficiently sought out. The other thing that was not paid sufficient attention to is knowledge possessed by locals. Lots and lots of people knew there had been landslides around. It doesn't take a geologist to know the land where a community lived for centuries, the movements of the moon and of the winds, their ways of combining with humidity and temperature, etc. Okay, so for instance, the very name is a bit of a giveaway. Monte Talk is short for Patalk, spoiled, rotten, or damaged. Okay, so then what are the right tools and the right purposes? So we think it's not we claim that in the Bolling, keeping the Bolling sense of Bolling character of objectivity, that you do that because it enjoins you to find the right tools for the right purposes. What are the right tools and purposes? Well, that requires judgment, and it can be done more or less objectively or responsibly. And as I've said, it's a hard duty for any single person or group to undertake. So one of the things one ought to be thinking about with this regard is how to structure scientific activities and the use of science so that you make better the chances of having the right kind of viewpoints to see all the aspects that will help you settle on what really are the right tools and purposes. So, objectivity for responsible science use. Given the context, including the possible moral costs, we think that the decision not to use or look for local knowledge was irresponsible and non-objective. So, our conclusion is, for responsible science use, when you're engineering objectivity, what you ought to be coming up with is what Eleonora calls objectivity to be found. That is, what you're doing is you want to expose that this is a concept. It retains its it retains its ambiguity, and it puts onto the person who is using the scientific product, or the group that's deciding to use this scientific project, it puts onto them the heavy duty of finding what objectivity requires in this case. So that's an odd bit of engineering that you might not have been, and an approach that you might not have been doing so often yet, that we recommend is trying to figure out how to leave concepts ambiguous, but expose what's involved in using them, as in this case, that leaving it ambiguous means that really you've turned it into objectivity to be found. And this intertwines the moral and the epistemic. Thank you.